Hello everyone, my name is Marine Jouvent. I will present you here the most recent project of the Goldfield window team working on the Grenville Front. So here is the Archean restitic deep crust from the Grenville Front, southeast of Val-d'Or with the S-type Granite Cycle. So this research was funded by metallurgs, by the Laval University, and we also teamed up with the Minister of Natural Resources and Forest for this project. So the Minister funded, they provided us field work logistic for the last summer. They also funded some analysis, and they are also fully funding a master thesis, the master thesis of Jérémy Darvaux, who is here today. The team is composed by, so the team of the Goldfield window working on the Grenville Front is composed by Carl Guillemette, who is professor at Laval University, as you all know, by Antoine Godet, who was working at University Laval, but who now left to work on the Geological Survey of Canada, Jérémy Darvaux, who is doing his master thesis at Laval University, Christian Loreich joined the team recently, his research associate at Laval University. There is Myriam Côté-Roberge, geologist at the Minister, and 3 field assistants that we had during the field, and also myself, so I'm Marine Jouvent, working as a postdoc in Laval University. As it was repeated several times in the past days and also past years, the objective of the Goldfield window is to constrain the fluid, metal and ligand production, transport and mobility. So for that we have a strong interest in studying the metasedimentary belts of the superior craton, because all these metasediments might be a potential source for fluid and gold generation. So as you have seen in the previous talk this morning, there is a strong focus on our team on the upper crustal metasedimentary rocks, and we focus on the devolatilization reaction. So we liberate gold and fluids during these reactions. So it's prograde dehydration reaction and fluid generation. But these rocks still have a lot of gold and water inside. There is water in biotite, in hornblende, etc. So we want to know, we are missing what happened at depth when the rock melts at granulate facies at higher grade. What happened to all this fluid and gold? So to understand the full cycle of the water and of the gold, we want to study the granulate grade rocks from the sediments to the schist to the granulites, then liberating fluid by partial melting, which goes upwards towards the shallower level of the crust, and which crystallize in terms of S-type granites. Yeah, that's why we want to study it's important for us to study the granulite and the restitic granulites. So the granulites rock, often related to deep restitic crust, are present in several metasedimentary subprovinces in the superior craton. We have some in the Ashwanipi, in the Opinaka, in the Quedeco, and as you've seen this morning, we have done, or the Goldfield window teams have done several transects in the Quedeco and Pontiac from moderately or from poorly endowed to moderately endowed area to highly endowed area. So and in the Quedeco, in the poorly and moderately endowed area, there is granulate grade rocks, so we can actually study that. But in the Pontiac area, it's strongly endowed, so it would be very interesting to study the granulite grade rocks. But there is no granulite grade rocks, so we need to find where they are. So if I focus on the Pontiac, there is a large amount of S-type granites. It's a Dussel batholite here in pink. And to create such amount of granite, there should be a lot of metasediments that melted. There should be somewhere a lot of restitic metasediments so it would be orthopyroxene-bearing rocks with in situ locosomes. We want to know where are these metasediments because it's very important for us. So can it be the metasediments, can the source of the dussel batholith be the metasediments in the Pontiac itself? So these metasediments here. We think that no, because there is a Barrovian sequence inside with biotite, garnet, staurolite, sillimanite, kyanite, but there is no orthopyroxene rocks. It has not melted. So it's not here. And in addition, the prograde metamorphism in these metasediments was dated at 2657 million years, and it post-dates the onset of the dussel batholith crystallization, which is at 2670 million years. So the source of all this S-type granite is missing, and the source underwent the prograde metamorphism before the Barrovian sequence at the surface. So the source is not in the Pontiac metasediment, so where it is. We have a clue for that, which is the forbidden Grenville Front, or Grenville orogeny. So here is the alloctone of the Grenville province. But there is also the para-autochthonous, which is very important because it's an Archean protolith. And it has, we know from the literature that it's Archean protolith, that it has high pressure granulites, bearing rocks, reworked by Grenvillian orogeny. So because it's just next to the Pontiac and it's granulate grade rocks, can it actually be the source of this dussel batholith? That's what we will study. So we are here southeast of Val d'Or in the Grenville Front. Here is the Pontiac with the dussel batholith in red. Here is the Abitibi, and the Grenville Front is bounded here by the Grenville Front itself and the Dorval detachment on the south. The area is mostly dominated by migmatitic paragnesis with in situ locosomes. It's cross-cut by pegmatite dikes, as you can see here. And the paragnesis are cross-cut, the high temperature paragnesis are cross-cut by low temperature mylonites with a Grenvillian orientation. You can see along the Grenville Front or along the McLaurin Trust. And on the northwest of the McLaurin Trust, there is aluminosilicate bearing rocks. So it's migmatitic paragneiss with kyanite, sillimanite, garnet, biotite, and melt. And as soon as we go southeast of the McLaurin Trust, we have the appearance of orthopyroxene-bearing quartzo-feldspathic gneiss. And in the whole area, there is mafic granulites, which are either concordant to the foliation with mafic lenses, or also some discordant dike swarm. The point is that some people, some authors like Martignol and Martela in 2005 stated that this whole mafic granulite was Proterozoic. But is it really Proterozoic? Because they say that it's high pressure granulite, and we don't think that Grenvillian orogeny could create such a fabric, such a metamorphic assemblage. So is it really Archean or not? Because if it's not, then we have nothing to do there. And as I said, there is some controversial ages. Some people say that it's high pressure granulites are Grenvillian, but some other people, like Chris Lambert, say that on the north of the Dorval detachment, so in the area that I presented here, which is here, the uranium late monazite ages are all Archean, and on the south of this Dorval detachment, all the ages are Grenvillian. So, and in addition, a pegmatite which is in the Grenville Front north of the Dorval detachment was dated. This pegmatite cross-cut the foliation, and it's dated at 24 million years, so it's definitely Archean. So the foliation, which is cross-cut by this pegmatite, should be Archean. So what is it? Is it Archean, or is it Grenvillian, this metamorphic assemblage? So to make sure of that, we did in situ lithium hafnium dating on garnet. So this is the work of Antoine Godet, which was recently submitted. So he dated 9 samples from metasediments and mafic granulates, coupled with trace element mapping on garnets. And all the ages are Archean. So it looks like the Archean that the assemblage, the metamorphic assemblage, is Archean. So if rock-forming minerals are Archean, then assemblage is Archean. But it's so we can actually be sure, or almost, that the source of the batholith can really likely be the metasediment of the Grenville Front, because we have an Archean protolith. The metamorphism is Archean. There is granulite facies rock with restitic migmatite. It's right next to the Pontiac, so then we can study how much melt was generated during the partial melting. But it's called the Grenville Front, so there should be probably something Grenvillian, but at least not completely. So we are fine for that because we have Archean garnet ages. But this Grenvillian overprint, is there any? If there is nothing, no overprint, then we can do ultra-low detection limit for gold. But if it's partial, then how much, and what was the thermal overprint on the Grenville Front? So that's what we investigated with thermochronology, with in situ rubidium strontium dating on biotites. Here you have few spots on the biotites. What is important for us is that the closure temperature for the biotites with rubidium strontium is from 300 to 500 degrees. So we actually are getting a cooling age. This is a work of Christian Lorage, who dated in situ rubidium strontium on 13 samples from metasediments and myelonite. So we dated the myelonite and away from the myelonite. And so it's in situ, so it allowed us to date different textures, like in pressure shadow, close to garnets, in the matrix and so, and also coupled with, like in the same samples where we dated the garnet. You can see some holes in the garnet. And the result of that is that we couldn't find a single biotite which was Archean. Like all of them have Grenvillian ages. The peak is at Rigolet age, around 900 million years. We have some ages younger and older that we are not sure yet how to interpret. It's still a work in progress. So there is a thermal overprint during the Grenvillian orogeny. So this answers our question that there was partial thermal overprint. So then it would be probably like we would not go to the direction of ultra-low detection limit on gold because there was thermal overprint. So in conclusion of all that, so we can say that the Grenville Front is a very good candidate for the lower crust of the Pontiac because it has granulate facies rocks, because the protolith is Archean, because the metamorphic assemblage is Archean, the garnets are Archean, but there was a thermal reequilibration on Grenvillian orogeny. So we actually have a whole crystal section with the full cycle of the fluid and gold generation, from the sediment to the schist to the granulite, liberating fluids and migrating to the shallower level of the crust, making Pluton. So it's a full S-type Granite Cycle. So what we will do next, so we will do some phase equilibrium modeling on the metasediments to know how much melt was generating during the partial melting, what is the composition of this melt, what is the age of the melting. We will do some tests for the iron-magnesium diffusion due to the Grenvillian thermal overprint. We need also to know better the age of metamorphism, so more precise dating with less uncertainty, shorter, smaller uncertainty on the garnet ages, uranium lead on monazite and zircon. Jérémy Darvaux on his master thesis will date and do the phase equilibrium modeling of the mafic granulites to compare it, because we have different lithologies, so it's very good for us to study the different rock types, because they can provide us a different part of the PT the PT condition and different timing, so it's good to combine it. We want also to know when the Pontiac started to be deposited and on what. We will do detrital zircon to confirm that these metasediments are really the source of the batholith, of the Dessel batholith. And very important is because we have granulite facies rock, so it's super deep, really deep. And then what is below that might be the basement. So it's a very good place to investigate if there is potentially the basement of the Pontiac somewhere. And a good candidate for this is the gneiss of the Bay Lake, which is just here. So it's right next to the Dessel batholith. So we would expect that these orthogneises have S-type granite affinity. So we went there, and so it's a granodioritic orthogneises, very deformed, with some lenses of mafic rocks. And we've done the geochemistry on it, and it has actually TTG affinities. So it's very good potential candidate for the basement. So we are actually, very soon we will date the zircon there. And if it's a basement, then it has some major implication for the tectonic evolution of the superior Cretan. Also, so we were in this area here, and we found the potential lower crust of the Pontiac in the Grenville Front. But also it was seen by FOR in 2003 that with geophysical methods we see some geophysical lineaments with gravimetry and magnetism, and we can actually see the continuity of the Cadillac-Lardol Lake fault, which was moved by the Grenville Front, and we could find the potential lower crust of the ABTB in the Grenville Front, so we want to go there this summer to investigate if it can really be the meta ABTB, and to check this mafic gneisses and to date them. Thank you.